Hello everyone. Till now we have come across towards the notion of current, potential energy, and potential difference, which is nothing but your voltage. Also, we have learned about the circuit with series connections and parallel connections regarding your resistances. Now, we have also learned about EMF in the last class. Today, what we will be doing, we will be finding out the equation for current. Equation for current. So, what is this equation is for? So, we will be connecting this current and voltage in some way. Okay. So, till now we have learned Ohm's law, which states that if all the conditions are unchanged, then the voltage between 2 points is proportional to the current flowing through that point. Uh, so we have learned this thing. V is proportional to I, and we say that when we remove the proportionality symbol, R appears, and this R is nothing but your resistance. But how this happens? So logically we have learned little bit कि whenever potential is nothing but the energies between 2 points. So let's say this is A and B. So if this is the where the current is flowing like this. So if here more ions are there and if here less ions are there, so here for each ion more energy is required, but here less energy is required. So whenever, so this tendency will be there, so to push this ion from point A to point B. So this is logically we can say that if I increase this energy difference between 2 points, that means V, then the current will increase because of the push. But let us today prove this mathematically and using our logical derivations. So for these derivations I am taking a conductor like this. This is a piece of conductor, let's say, having length L and the area is A. So the cross sectional area is A. Okay, fine. Now let's say in this conductor there are some free electrons. So let's say n electrons are there. So n is the number of electron per unit volume. So electron density you can say. That means in unit volume how many electrons are there. So this is electron density. Now we have already known that if there is some electric field and if I put a charge here, so what is electric field? Electric field is nothing but the force per unit charge. So electric field is coming like this. That means the positive sides are here and negative sides are here, because from positive electric fields go away and it goes away towards negative, right? So if I have an electron here, this electron will feel a push in the opposite side, right? Because it will be attracted by positive side and it will be repelled by your negative side. So the electron will have a push, it will experience a force, right? Okay, so that means the force on this electron will be electric field into the charge of electron. Now there is a minus sign because the charge of my electron is negative and it goes in the opposite direction of the electric field. Okay, so the charge of electron is negative. Acha. Now let us talk about something which is called drift velocity. Now what is this drift velocity is all about? Okay, So your drift velocity is that velocity with which this electron move. Okay, so in the next page we will be talking little bit about drift velocity, then we will be continuing to our old thing. So drift velocity. So I said that if an electric field is there and if a charge particle is there, it may be a positive charge particle or negative, it will feel a force, right? Now drift velocity, now you know that in some conductor, most of the conductors, when they move, when this charge moves, they create collisions, they indulge themselves into the interaction with other molecules and other charged particles inside that material. So they cannot go straight, they always collide, and in that, after that collision, they move. So you cannot just say one constant velocity. So ultimately we can find out the average velocity by some relationship. We will be talking later on about that, and that velocity is called drift velocity. So what is a drift velocity? Drift velocity is the average velocity of electron under the influence of an electric field. So I can say this is the average velocity of charged particle, in this case electron in this case, under the influence of an electric field, because only then this thing will move, like charged particles will move. So this is noted by Vd. Okay, so this is important for our further study. So that is drift velocity. Okay, now coming to here, so I say that n is the electron density. So in little bit of volume, in unit volume, there are n electrons. So how many electrons will be there? So that I can say that a total electrons will be the volume, total volume into small n, because small m is the number of electron per unit volume. Now what is the volume of this thing? If the area is so you can say that how it is area. So it is actually a 3D object. Okay, but we are just drawing like this so that the picture remains a little bit simple. So how to find out the volume? Volume will be area into length into n. So that will be the total number of electron here. Now I say that the current is charge flowing by time. So the charge flowing, so I can say that a single electron is having E amount of charge. So this much of electrons will be having this into E amounts of charge. So I can say that A L N into E by T, and from that I can write this is A N E L by T. Now if the electron is moving throughout this L, from this portion to that portion, that means it is covering L distance and the time is T. So this distance by time we can write as Vd, that is your drift velocity, which I have told you here. So we can introduce drift velocity here. So ultimately we got I is equal to NEA Vd. So I'm writing this again. So we got I is equal to NEA Vd. Okay. Now I will be introducing some more term here that will be useful for us. Okay. Now we can relate I with Vd, that means the velocity of the electron. But I need to get some relationship with the potential which I have applied. Now there is a relationship between your Vd and your I. So we are coming to that. So we can see that the velocity of the electron will be proportional to the electric field given. Now why it is so? Because see, more we will give the force, the transfer of momentum will be more. So this is some relationship. Okay. Now I can introduce here, if I remove this thing, I will get some constant mu. Okay. What is this constant is all about? This constant is Vd by E, and this is called mobility. What is that? Mobility is the amount of drift velocity produced per unit electric field. So if you give 1 unit electric field, how many drift velocity will be produced, that will be your mobility. So like for electron, mobility is very high because it's a small particle. And if you talk about proton or something like heavier ions, so in that case, now proton cannot move, you can understand that. The ions can move, the whole atom can move in that way. So if you are talking about whole atom, then the mass is higher, so in that case mobility will be less. Okay. So this is a relationship between Vd and mu. So I can introduce this relation here, NEA. So instead of Vd, we are writing mu into E. Okay. So this I have gotten from here. Acha. So I have now a relationship between I and E. Now one more thing is there at last to do, and that is the relationship between E and, so I am using another color here, and down portion I am doing this, E and the voltage. So we know that the work done is force into displacement, that is L, right? So if I divide both sides by Q, I will be getting, so I am doing here, I will be getting W by Q, F by Q into L. Now W by Q is your potential, that is your potential difference, you can say also. F by Q is your E, and this is your L. So from here, so this is a very important formula you have to remember. You must remember this formula. So from here we can do one thing. We can substitute the E, which is upside. So if I substitute, I will be getting NEA mu. So instead of, I can write this V by L. So you can see that this first portion, so I am using another color. So this first portion, N, is the density of electron in that material, which is a constant, which is depending on the material itself. E is the electronic charge, A is the area of that material, mu is the mobility of electron, which is also like a constant term, L is the length of that material. So these all are materialistic property. So this whole thing depends on the material. Only V is outside part, like which you can give externally. So this whole part is nothing but your resistance, and V is there as usual. So this is the way we have gotten the Ohm's law again. Okay, so this is the actual proof of Ohm's law. Now why we need this thing? because this term, this thing we have to remember. This is very important to remember. And the last part is very important to remember. Our Ohm's law is very important to remember. Okay, so these things we need. So from this we will be getting some data. How kind of data? What kind of data? So we know that I is equal to NEAVD. So I can say that the VD is I by NEA. So we can say like this. So what are the things that this VD depends on? So we know that the drip velocity is inversely proportional to the area. So that means if I have some thick wear, then the VD will be more or less. So more the area, the VD will be less. Okay. VD is also proportional to 1 by n, that is the inversely proportional to 1 by n, that is the number of electron. So smaller the number of electron, lesser will be collection and VD will be more. Simple logic. Okay. So in case of area also the same thing will happen, because if the area is small, obviously the the arrangement of electrons will be in such a way so that the collisions is less. So in that way also the drip velocity will increase. So these two factors we can get. Also the current will be proportional to the drip velocity. So if I know the current, I can also understand what will happen to the drip velocity. So this thing was all about. So this equation is the equation of current, which is very important. Now after this topic, what will come, that thing is your power. Okay, so power in electric circuit. So power in electric circuit. Now when there is a resistance and the charge is flowing, the charge dissipates some of its energy, because I have said that charge wants to grow from higher energy level to lower energy level. So while going, it emits some sort of energy in forms of heat or radiation. Okay, so what is that energy? So we have to find out how much work is done by the charge. Okay, so what we can do, we can write that the work done, W is equal to V into Q. Right? Now we know that current is Q by T. So Q is equal to I into T. So we can here write V I T. So this is the work done by current I in time T. Also we can use this formula here, that is V is equal to IR. If we use this formula here, we will be getting I square RT. So this is the work done, or you can say the energy dissipated by any charge while flowing through any circuit. If you know the I, if you know R, if you know the time for flowing, so you can find out the total heat dissipation. Okay. Now if we talk about power, so we know that the power is work done by time. So the power will be I square RT by time. So this is I square R. So if you use Ohm's law again, so we can even write this equal to V into I. Why? Because my IR is equal to V. So I can replace that. I can take one IR from here and I can write V into I. So this is also very important to remember. So these are some facts which you need to know. Why the power is emitted? Because here the potential energy is higher and here the potential is lower. That's why the current is flowing like this. So the positive you can say positive charges are flowing from uh, left to right. Why? Because in the right side the energy is less, so it is emitting the energy in forms of heat or radiation, and this energy is nothing but your work done, and the power here is that work done per unit time. Okay, so what is the unit of this power? The power is denoted in watt generally. Then you have horsepower, okay, and then you have dot also. So that we will be coming slowly. Till now this much is important. So today we have learned this much things, and one more topic is there in your book, which is called fuses. Now, what is fuses? As we have come across power, so we know that when current flows through the circuit or through some resistance, it emits heat. Okay, so what happened? This using this property, we can make our what you say home wiring very safe. Why? Because we used many equipments in our home. These equipments are like this equipment works in some limited amount of current. So if you give more current than what is required, then the circuitry can burn. So it is very important for us to limit the power supply. So let's say if my some smartphone is getting charged somehow with some adapter. Now this adapter can handle only, let's say, 0.5 ampere, but my power supply is giving 2 ampere, which is very high, which is almost 4 times. So what will happen? My adapter circuit can burn, even that can harm my smartphone, which I don't want. So what we use? We use a fuse. What is the fuse? Fuse is a piece of wire. Okay, so it looks like something like this. So it's a piece of wire is there, thin wire. So this wire is having some certain resistance, such a way that whenever current more than sufficient current is flowing through the circuit, the heat produced will be I square RT, and this resistance is such a way that this heat what will be produced will be same as the melting point of this material itself. So what will happen if, let's say, the fuse, this is the fuse for 1 ampere. So if more than 1 ampere current is coming, so what will happen? This heat produced will be enough to burn the fuse itself. So what will happen? The fuse will automatically break, and more than 1 ampere current will not be able to enter my house. Okay, so in that way it will restrict the amount of current flowing through the circuit. So that's why we use fuse. We have fuse of 5 amp, 2 amp, 15 amp, like that. Okay, and most of the equipments are also having fuse nowadays. So you can check your what you say equipments. Okay, there is a small piece of glass having 2 cap up and down, and there is a small thread. So that is a fuse, and it works like that. So today we have learned these things. Please take a note in your notebook so that we can go further with this. So see you in the next class.